Hello, we're on 6.04 for Pre-Calc today, and we are going to be talking about more with vectors, and specifically about the dot product of vectors. All right, so what are dot products? It's kind of a combination of multiplication and addition, and they're important for finding angles between two vectors. And we'll talk about that formula later on. So how to find your dot product of u and v, let's say. So let's say vector u in component form is u sub 1, u sub 2, and vector v is v sub 1, v sub 2. So to find your dot product, so we represent it by just a dot, you're going to take the first component here, u sub 1, and multiply it by v sub 1. And then we're going to take u sub 2 times v sub 2 and add it to that. So u sub 2, v sub 2. So we multiply the first components together, u1 times v1 plus u sub 2 times v sub 2. And what's kind of cool here is that actually gives us a scalar quantity. So a number as opposed to another vector. So it does not give you another vector, it gives you a scalar quantity, so just a number. So let's practice finding the dot product given two vectors. So letter A, let's do 4, 5, and 2, 3. Okay, so we'll do this one together. So first I want to take 4, and I'm going to multiply it by 2, and I'm going to add that to 5 times 3. And then I'm just going to multiply and add, so 8 plus 15. So my dot product is equal to 23. All right, let's try another one. So this time I want you to find the dot product of 2, -1, and 1, 2. So pause the video and do the same thing that we just did. All right, so again, you would do 2 times 1 plus -1 times 2. And then 2 minus 2 would give you 0 for your dot product. Let's try one more. And I'd like you guys to do this one on your own completely. So 0, 3, the vector 0, 3, the dot product of that with 4, -2. Pause the video and go ahead and try that one. All right, so you should have gotten -6 for your dot product there. Again, on your papers, I should see all the work written out like we did for letter A and letter B. All right, next let's talk about the properties of a dot product. I'm going to run out of room here, so I'm going to start on the next page. Properties of dot products. So first thing is it is commutative. So if I do u dot v, that will equal v dot u. Okay, another property. If I take 0 and find the dot product of 0 vector and another vector, it will give me 0. Because remember, 0 vector is just 0, 0. So everything you multiply times v would give you back that 0. If I took vector u and found the dot product of u and v plus w. All right, so if I find the dot product of a vector and the sum of two vectors, one of our properties is that we could take the dot product of u and v and add that to the dot product of u and w. So again, that would give you a scalar plus a scalar, so you'd end up with a scalar quantity again there. And the last one we'll talk about is if we take c, which we'll say is a scalar quantity, and multiply that by the dot product of u and v. That's the same thing as taking c and multiplying it by vector u, which would give you another vector because you're just multiplying it by a number and finding the dot product with v, or taking u and the dot product of c times v. So you could multiply it by one of the two vectors and then find the dot product, would give you the same answer either way. All right, so let's try and use some of these to do some multiplication and some dot products. So first I'm going to give you u, vector u is -1, 3 in component form. Remember, it's in component form. Its initial point is at, and you guys said 0, 0, and the terminal point is at -1, 3. Vector v in component form is 2, -4. So initial point 0, 0, terminal point's 2, -4. And I'm going to give you one more. Vector w in component form is 1, -2. All right, so the first one we'll do is finding the dot product of u and v, and then multiplying that by vector w. Okay, so first start by thinking about, do you think this is going to give you a scalar quantity, so just a number, or is it going to give you a vector? All right, so let's dive right in. So first, let's do our dot product of u and v. So u dot v, I'm going to take, so here's u and here's v, so I'm going to do -1 times 2 plus 3 times -4. Multiply those together, so -2 minus 12 gives us -14, a scalar quantity. So this right here is -14. So now I'm going to take this scalar quantity and multiply that by vector w. So this right here is -14. So I'm going to take -14 and multiply that by vector w, which is 1, -2. So with scalar multiplication, so we have a scalar times a vector, you're just going to distribute that in. So this would give us -14 in component form, and -14 times -2 would give you +28. So our answer here is a vector. So we got a scalar from the dot product, multiplied a scalar times a vector, gives you a vector. Let's do this. Next one, let's do u dot 2 times v. All right, so pause the video and see if you can try and do this one on your own. All right, so vector u we know is -1, 3, and I want to find the dot product of 2 times vector v. So v is 2, -4, so I'm going to just multiply that by 2. So 2 times 2 is 4. -4 times 2 would be -8. So this right here is 2v, 2 times vector v. So when I take a scalar quantity and multiply by a vector, I still get a vector. Now I'm finding the dot product, and whenever I find the dot product, that should give you a vector or scalar. A scalar is the answer. All right, so pause the video if you hadn't yet, and finish this up by finding the dot product of those two. And you should get -28 for your answer there. Again, I should see the work written out on your papers, and that is a scalar quantity. It's not a vector. It's a number, which is a scalar. All right, let's do 3 times vector u dot product with w times vector v. So first try to think about, do you think this is going to be a scalar or a vector? And then I'd like you to pause the video and solve it. So figure out what the scalar or vector might be. All right, so first you should have done inside your parentheses, so 3 times u, and then the dot product with w. So 3 times vector u, -1 times 3 is -3. 3 times 3 is 9. And we're finding the dot product with w. So again, I should see your work of -3 times 1 plus 9 times -2. And that should have given you -21. I'm skipping those steps because you guys should have done those on your own. So this is -21, and I want to multiply that now by vector v. So 3u dot product with w times v gives me -21 times vector v, which is 2, -4. So your final answer would be -4284, which is a vector. Okay, so again, we got a scalar quantity from the dot product times a vector would give you a vector. So anytime the dot product is multiplied, when your dot product is multiplied by a vector, what do you get? And when your dot product is multiplied by a scalar, what do you get? Pause the video and write down whether you get a vector or a scalar when doing either of these things right here. All right, so when the dot product is multiplied by a vector, so dot product is a scalar quantity, so that's like a scalar times a vector would give you a vector. If you take the dot product and multiply by a scalar, so the dot product is a scalar, and if you multiply that by another scalar quantity, that's going to give you a scalar quantity. Okay, so the next thing we're going to do is find the angle between two vectors. So far with vectors, we've talked about how to find the direction angle. So that's if you're given one angle and just finding the direction of that as an angle. So this one, you're going to be given two vectors because we're finding the angle between the two vectors. We're going to assume these are non-zero vectors. We're going to use the formula cosine theta. So for our direction angle was tan theta equals b over a. This is the angle between two vectors is cosine theta equals the dot product of the two vectors over the product of their magnitudes. So remember here, to find the magnitude of a vector, you take the square root of a squared plus b squared. And our dot product gives us a scalar. So when we multiply and divide all of these together, it should give us a scalar quantity. And then you're just doing inverse cosine to find that angle. All right, so let's do an example. So find the angle between vector u, which is 4, 3, and vector v, which is 3, 5. Make sure you draw a picture. And let's round to the nearest 1/10 of a degree. Okay, so we're going to just use this formula here. So I've got cosine theta equals the dot product over the product of our magnitudes. So before, let's write the formula out so we can start to memorize it. So our dot product over the product. So multiply our magnitudes together. All right, so first let's go ahead and find our dot product. We're going to need that for this formula. And then I want you to find the magnitude of u and the magnitude of v. Pause the video here and find those three things, and then we'll meet up and finish it together. All right, so your dot product should have been 4 times 3 plus 3 times 5. And that should give you 27. Our magnitude of u, so here's u, we're going to take the square root of a squared plus b squared, so 4 squared plus 3 squared. So that's 16 plus 9, square root of 25 is 5. Square root of v is 3, 5, so the square root, magnitude of v, which is 3, 5, sorry, is 3 squared plus 5 squared. So that's 25 plus 9. 9 plus 25, which will give us the square root of 34. So now I'm going to substitute these all back into my formula. So I've got the cosine of theta equals my dot product, which is 27. Apologize for all the extra lines. Over the magnitude of u, which is 5, and the magnitude of v, which is rad 34. So now we want to find theta. Whenever we're looking for theta, we can do our inverse cosine. Now, I will say when you use the alpha y equals, this sometimes gives you an error if you don't rationalize it. So you kind of have to play around with your calculator a little bit. I'm not too worried about you rationalizing it if you can get it to work with your calculator, because I'm really just looking for theta here. So if I pull this up, and I want it in degrees, so I don't think I wrote it, but I said it, to the nearest 10th of a degree. So we would do inverse cosine of 27 divided by 5 rad 34. Oops. I think on some of these calculators, though, I'm just going to redo that. Inverse cosine of 27 divided by 5 rad 34. So this one gave us an error. So I think on these, we can actually, let's try it using the alpha y equals. And if that doesn't work, then I just have to rationalize. So multiply the top and the bottom by rad 34. But I believe one of these ways works on these calculators. It's a little finicky on the newer calculators. There we go. So you have to use y, the alpha y equals, and then it gives it to you. Again, if that doesn't work on your calculator, just multiply the top and the bottom by rad 34 to get the radical out of the denominator. So now I'm going to write out that entire decimal. 22.1663458 and then it says to round to the nearest tenth. So that would be 22.2 degrees for my final answer. And then you just want to double check by drawing your picture. So here I would graph my vector for 3. Remember it in component form. This is vector u. Your initial point is 0, 0. Your terminal point is 4, 3. And the other vector is 3, 5. 5. It's vector v. And you'll see here it is quite a small angle, an acute angle between the two vectors. So 22.2 degrees seems like a reasonable answer. All right, let's do one more, or a couple more of those actually. So find the angle. This time, let's do it in radians. Between vector u at 2, -1 and vector v, at 1, 2. And make sure you draw a picture as well that supports your answer. All right, so you're gonna do the same thing that we did in the last one, number 3. So pause the video here, write out your formula, and find all those components for the formula, substitute them in, and find your angle in radians. All right, so first your formula should be cosine theta equals the dot product over the product of the magnitudes. So first, let's go ahead and find our dot product. So that we take 2 times 1 plus -1 times 2. And that gives us 2 minus 2, which is 0. Now let's find the magnitude of u. So again, to find your magnitude, you're taking the square root of a squared plus b squared. So that's going to be 2 squared plus -1 squared. And I'm getting those from this vector right here. Next, I'm going to find the magnitude of v. So that's this one right here. So I'm going to take the square root of a squared plus b squared. So another formula you have to memorize. And then you're going to simplify those. So we get 4 plus 1 is 5, square root of 5. And then for v, also square root of 5. All right, so now we substitute in and we get cosine theta equals 0 over rad 5 times rad 5, which will just give us 5. And 0 divided by 5 is just 0. So now this also could be on a no calculator portion, where you could be asked to find theta in radians or degrees without a calculator. So remember, anytime you have sine or cosine equal to 0, 1, or -1, that tells us it's going to be on one of our axes. So we're looking for where cosine is 0. So you're not going left or right at all. So either 0, 1, or 0, -1. If you did put it in your calculator, you could put in inverse cosine of 0, and it gives you your 90 degrees. So we know it's either going to be 90 or 270. And if you look at your picture, and we know 90 degrees is pi over 2, or 3 pi over 2 for 270 degrees. So now for vector u, I'm plotting the point 2, -1. And then the initial point is always 0, 0. So that's vector u. And then vector v is 1, 2. So you can see here our angle between them would be our 90 degrees, or just pi over 2. So you don't need to give both angles here. You don't need to say it's 90 or 270. 270 would be if you went the other direction. We can just give that one angle, which is 90 degrees, because you're not asking, like in before, we're asking what are the possible angles. Here we're asking what's the angle between these two. And between the two vectors would be 90 degrees, or in radians, pi over 2. All right, number 5. So a little bit different on this one. I want you to actually find the dot product, so u dot v, given, so where theta is the angle between, sorry, it's not cooperating again, is the angle between u and v. Theta equals pi over 3. The magnitude of u is 4, and the magnitude of v is 2. So since we're given theta and we're given the magnitude of u and the magnitude of v, and we're asked to find the dot product, we can use our formula to find the angle between them, since we're given the angle between them. So here, if we're not given the two vectors, we can't just do the dot product of them. So we're going to use cosine theta equals u dot v divided by the product of their magnitude. So the magnitude of u times the magnitude of v. So I want to solve for u dot v. So I'm going to substitute in everything I know so far. So I know that theta is pi over 3. And I know that the magnitude of u is 4 and the magnitude of v is 2. So I'm multiplying those together. And I want to solve for this dot product here. So first of all, I know 4 times 2 is 8. So to get rid of the 8 here, I'm just going to multiply both sides by 8. So I get 8 times cosine pi over 3 equals my dot product. So now I just need to figure out what 8 times the cosine of pi over 3 is. So if you don't have it memorized, then you would draw pi over 3, which is 180 divided by 3. So that's 60 degrees. That's quadrant 1. Drop your bow tie. Now I have a 30, 60, 90 triangle, which is in the ratio of 1 rad 3 to 2. They're all positive. Cosines adjacent over hypotenuse. So that means the cosine of pi over 3 is 1/2. So 8 times 1/2, which is 4. So the dot product of u and v would equal 4. So you're just using the formula in a different way to solve. All right, let's just do a couple practice for you guys. So that was number 5. So for number 6, given u equals 5i minus 3j, and v equals negative 2i minus 5j, find u dot v, so the dot product. So this time given a linear combination, so you might, if you need to, you can start by rewriting them in component form and then find the dot product. So if it helps you, you could rewrite it as 5, negative 3, and negative 2, negative 5. You do not have to do that, and sorry about all those extra little lines that it keeps making. Negative 5 and negative 3. Or you could just do 5 times negative 2 plus negative 3 times negative 5. Add them and you should get 5. Again, I want to see on your papers all the work and that you've checked it with my 5. So if you didn't do that, go back, pause the video here, show all the work, and make sure you get 5 for that one. All right, let's do one more of these. So u equals negative 2, 5. And v equals negative 4, 4. I want you to find, that says find, oh my goodness, negative u dot negative 3v. So find the dot product of negative u and negative 3v. Pause the video and do that right now. All right, so you should have gotten negative u to be 2, negative 5, and negative 3v to be 12, negative 12. And then you can go ahead and find their dot product. So you might write that out first. So negative u is 2, negative 5. And negative 3v, so I'd multiply everything through by negative 3, would be 12, negative 12. And then find the dot product of these two. So 2 times 12 and negative 5 times negative 12. And your final answer should be 84. Okay. Let's try do 2 more. So this one, I think I said that was your last one, but I was just kidding. of that type. So u is -4, 3. That says -4, 3. And v is 4, 1. Find 2u dot v times vector u. Pause the video and do that right now. All right, so you should have gotten 2u was -8, 6, and then found the dot product of those two. So 2u dot v, again, I'm expecting to see the work on your paper. I'm just going to give you the answer, though, should be -26. And then you want to take -26 times vector u. And so -26 times the vector -4, 3. Your final answer, again, I'm expecting to see work on your paper, not just the answers. Otherwise, I'll think you didn't listen and that you didn't do the work and you won't get full credit. Final answer should be the vector 104, -78. And this one will be your last one. So find the angle between the two vectors. Between vectors u and v if u equals 4i plus 2j, so written as a linear combination. That says 4i plus 2j, and v is -i plus 4j. And you can round to 2 decimal places. So to the nearest, let's say nearest 100th of a degree. Hundredth of a degree. So we want it in degrees here. Okay, pause your video now and try this one on your own. All right, so you should have gotten your dot product to be 4, your magnitude of u should be 2 rad 5, magnitude of v is rad 17. Again, I'm looking for all the work on your papers. It's hard to read this anyway. Not cooperating. And your final answer should be 77.47 degrees. 77.47 degrees once you do the inverse cosine. All right, please be sure to let me know if you have any questions, and make sure you learn these formulas. So you need to know that the formula for finding the angle between two vectors, and also how to find your dot product. Let me know if you have any questions at all. I hope to see you guys soon. I hope you're doing well. Pi out.